Okay, so hello students. Let's continue with our lectures on database management systems. And our today's topic will be data independence and data models. So um, first let us start with data independence, which is connected to our previous topic, which was yeah, this uh, views of the data. So here one thing is pending, that is what is data independence, so that we have to see first. So let us see on a whiteboard first what is it. Yeah, so let us see that first. Data independence, so the term is data independence. So basically we have seen till now that we have three levels of schema or abstraction. One is view level, second one is your conceptual or logical level, and third level is your physical level. Yeah, I hope you remember these things. So what is data independence first? This is very, very important term. That's why I thought to discuss it in this way. Basically, data independence means that a property of DBMS which helps you to make changes in the schema, that is structure of the database, at one level of the system without requirement to change the schema or structure of the database at the next level. So that is your technical definition. You can hear it out again by by making this video on the um, in the back form. Okay, so you can you have to hear it again. So the thing is, like, there are three levels. We have three levels, so let us understand it in this way. We have three levels. So if you want to make changes at one level, suppose at this level, then it should not affect this level, this next level. That will be data independence. So that makes our definition. If we want to make any change at one level of schema, then we don't have any requirement to change at next level of the scheme. So what we will achieve from this, it will help us to keep the data separated from all the programs, and that makes use of this data independence. So there are two types of data independence. One is your physical data independence, and second one is your logical data independence. So where it comes. So that the data independence between view level and logical level is your logical data independence, and the data independence between conceptual level and physical level is called as physical data independence. Now we'll see their definitions. What is physical data independence and what is logical data independence? Very quickly we'll complete it. Physical data independence kya hai? So what is it? Basically, physical data independence refers to the characteristic of being able to make changes at the physical schema without making any changes at the logical schema. For example, you can say that if you are making any changes in the storage size of the database, or if you are storing your data, if you are changing some place of the data from one hard disk to another hard disk, so it will not affect your conceptual schema. It will not affect the tables that are being stored, okay, that are being um, maintained at the conceptual level. So if you are making any changes in the storage size, you know, okay, so any alterations like that will not affect the conceptual level. That is called as physical data independence. What type of alterations can be done to the physical structure? They may include, like, alterations can include like the some new storage devices. One thing, new storage devices can be one modification that can happen. Another one, we are making any changes in the data structure, changes in data structures, okay, for the storage purpose. Next, okay, we are making any changes in the indexes, or utilizing some another file organization systems like B plus trees or hashing, as I told you in the last class. Okay, if you have not seen my previous video, please see that. So if you are making any changes in the indexes or file organizations, those kind of alterations can be made at physical level. So it should not affect your conceptual level. That is called as physical data independence. Okay, I hope you got some clarity on this. Next one is, we'll see now, logical data independence. What is logical data independence? So logical data independence refers to that if you are making any changes at logical schema or conceptual schema, then it will not affect your view level or external schema. If you are making any changes at this level, then it should not affect this level. Okay, so the thing is like user view of the data would not be affected by any changes made at the conceptual level. Fine. So the thing is like if you are making any changes, for example, if you are making any changes in the tables, if you are inserting some new data, you can think in this way. If you are making some insertions, deletions, updations in the tables, then should it affect your view level of the user? No, it should not affect. So that changes will not affect in any way your view level or external level. That is called as logical data independence. So these definitions are very, very important that you have to remember. So this is all about our data independence. I hope you got some idea. For any doubts, please comment. Let's go to our PPT now. Coming on to our next topic, that is our data models. What are data models and what are their users? How many data models are there that we have to see? And through that, we will move forward to our one of the very main models of the first unit, okay, that we have to see. So what is data model first? First thing you have to know. Data model basically is we are trying to model the data description, semantics. I will write down here. We are trying to model semantics. We are trying to model description. We are trying to model consistency, constraints. That is, I will just write down constraints in the data. So if you are trying to model out these two, three things together, that is called as data modeling. So it will provide some tools for describing the design of the database at each level of our abstraction. So you see, again and again, this term abstraction is coming in database. So how crucial it is to remember what is data abstraction. Okay. So here some another terms are also written over here in the definition. Describing data, its relationships, its semantics, its consistency constraints. Okay, and its description. Okay, that is one and the same thing that I've written over here. That is called as data model. There are different types of data models available. Mainly four data types, data models are available with us. First one is relational model. Second one is entity model. Third one is object-based data model. And last one is semi-structured data model. These are the types of data models available with us. So we'll see one by one what are they. First one is relational model. One is their overview. What is relational model? Basically, relational model means we are tackling or we are working with your data in the form of rows and columns. Okay, within a table. That kind of representation is relational model. That means we have tabular formats utilizing which we are designing our database. That is your relational model. This model basically will go on very much detail on it. We'll see one small example on it very quickly. What are they? Second type of data model is entity relationship data model. This one. So here we will talk about entities. I utilized this term in our previous lectures also. Entity is nothing but any object in the real world which has some existence in the real world. Relationship. Any relationship between those entities. So utilizing the objects, their attributes, the entities, and the relationship between them, we have to design one model. That kind of model is entity relationship model. Anyhow, by utilizing any of these models, we have to design our database. Okay, that is our main purpose. Third one is object-based database data model. So in this one, what we will do, we will basically extend our ER model in this one. We will Incorporate encapsulation, will incorporate inheritance, will incorporate methods, functions, objects. Utilizing those kind of concepts, we will have our object-based data models. Basically, we are incorporating object-oriented programming in this one. Last one is semi-structured data model. Semi-structured data model basically comprises of, mm, combination of some of the upper models. So it will permit some specification of data where individual data items will be utilized, and same different sets of attributes can also be utilized. So it will allow the specification where individual data items of same type may have different attribute sets. Some examples of the languages that it utilizes is XML, that is extensible markup language. It is widely utilized for representing semi-structured data. Okay, so let us see one by one very quickly all about it, because I don't want to make this video very lengthy, as I got some comments in my previous videos. So I'm trying to make it crisp and short, precise videos. Okay, so first one is like here you can see in our, to understand ER model and some of the models, we have to see these type of models also, hierarchical database models. So one of the models is hierarchical database models also, which will show the hierarchy in the data. Like there, it is kind of a tree type of structure. In data structures, if you have studied data structures, then you will understand it easily. But the thing is, like, there will be a root node which will show the overall structure. Then under that, what are its subcomponents? Then under that, what are its subcomponents? And finally, the leaf nodes. Like this particular example is shown for the college management system, in which overall root node is showing our college. Then it is showing different types of departments. Then under department, which are the components can be added. Like course, teachers, students are part of the department. Then finally under course, it is theoretical course, it is practical course. In this way, we can show hierarchically a model. So child node may have child node, that is this child node. It may have only a single parent node. This is your parent department. So this child node can have only one parent. And for any parent node, one to many relationship must be maintained. That means one parent can have many children, but one child will have only one. Okay, that kind of relationship should come. Very similar to that, there is another model which is called as network model. So we'll not spend so much time on this one. There is very small difference between hierarchical model and network model, that a child node over here can have more than one parent, like this child. This child is having more than one parent. So one child can have more than one parent, and one parent can have more than one child, as earlier in the hierarchical model. So here the type of relationship will be many to many. One child has many parents, one parent can have many childs. So this is network model. Third model is called as entity relationship model. In this type of model, we have some entities. Entities, for example, I gave you this example earlier also, student. Student is one entity, and student can have some attributes utilizing which we created schema. If you have not seen my previous videos of instance and schema, please do watch it. You will understand it. So student is an entity which is having some existence in the real world. Student is having some attributes like ID and age, as shown in this. Now we are taking one more entity, that is course. Course is also having real time existence in the world. So course is one entity. It is having some attributes as course ID and credits of the course. What is the relationship between student and course? That student studies course or student enrolls in the course. So that is your relationship. So that is being shown with some representations over here, like rectangular diagram, then elliptical form and diamonds. So these are the ways utilizing which these things can be shown. Entity, relationship, these are the predefined formats which you cannot change. So this kind of relationship, if in this way we are representing our complete database, it will be called as entity relationship model. It will come in very much detail in our further lectures, in which we will learn how to draw ER diagrams, ER models. Third type of model is the relational model. In relational model, we have to do representations in the form of tables. Tables are nothing but combination of columns and rows. These are the rows. These are the rows. And these are the columns. Okay. So here, the representation in the form of rows and columns will be called as relational model. So if we are showing our complete database in the form of relations, relations means tables, then it will be called as relational model. Next model is object-oriented database model. So we are utilizing our classes and their objects to represent some things. Class basically you can say the overall, the blueprint you can say. Okay, object, um, object will be like you can say it will utilize the identity. Okay, for examples, we can take some examples of class and object. So class will be like a template which will define some functions for an object, while object will be called as an instance of that class. So class, as I said, it is a blueprint. For example, a car. Car will be a class, or a class can have some attributes, like car can have some attributes like its weight, its color. Okay, so attributes will become like weight and color, and functions or methods will become like drive or brake. Okay, so I will show you these examples. Like here also some things are shown, but to understand it in a more way, the thing is like I have taken a class like car. Car is a class. Car is a, sorry, car is a class. Okay, car is having some attributes. Attributes like weight. It is having some color. Okay, so object of the class will be like an instance which will have some real values instead of some variables. Like you can say objects will be like your this only weight, color. Okay, so they will they will be the instance of that class. Like here you can see invoice. Invoice has some details. So invoice is a class and these are the objects. What are the other details that can be their ID, order ID? Okay, so if we are showing our database, if you have some entities in your database like this, which you want to show in this way by utilizing the objects, the classes, then it will become your object-oriented database models. So that is your object-oriented database model in which we are showing some of the attributes of our classes. I hope you got some idea. Okay, and it will utilize some inheritance also. What is inheritance? If you have superclass and if you have subclass, then subclass will inherit some of the attributes of the superclass. Okay, so that is about our object oriented models. So that's it about this lecture, students, and we will see further our next topics. By then, please subscribe my channel. Please do comments on it if you have any doubts. Visit my channel, and your subscription motivates me to keep running this channel. It will be very, 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 motivational for me. So thank you for your support. If you have any doubts, please comment, and you can mail me also. Another thing is I'll provide all my notes and my PPTs on my GitHub, and that link I will provide in the description. Thank you so much. Thank you so much for watching again. Please do visit and share my lectures. Thank you.